Okay, let's get into it. We are doing a deep dive today on a very specific but really essential piece of hardware for broadcast engineers. We're talking about the Thor broadcast F-2V4A-TxRx-RM. And our mission really is to cut through some of that super technical jargon. You hear video to fiber multiplexer and, it can be a bit much. We just want to unpack what this rack-mounted unit does and why it's still such an elegant solution for signal transport. So, let's start simple. What is this thing actually designed to move?
Well, what's really fascinating here is that this unit is basically designed to bridge the old world and the new.
The analog and the digital.
Exactly. It's built to take legacy signals. We're talking 2 channels of CDBS composite baseband video.
And CVBS, for people who might not know, that's your standard definition analog video.
Right, the kind you still see in a lot of security systems, surveillance, older industrial setups.
Yeah.
And it also handles 4 channels of analog audio. But the impressive part, the real engineering feat, is that it takes all 6 of those streams, bundles them up, and sends them across huge distances using only a single fiber optic cable.
Just one cable.
Yeah.
That's incredibly efficient, especially for remote setups. Okay, but that immediately brings up a question for me. We're dealing with traditional analog signals here. How does this thing possibly maintain broadcast-grade quality? I mean, doesn't analog quality degrade the second you touch it?
It absolutely would if it stayed analog. That's the key.
Ah,
The trick is in the conversion process. Even though you're feeding it analog, the unit digitizes those streams inside the transmitter right away. It then transports that data as an uncompressed digital signal, as modulated light. And then the receiver at the other end just converts it back to a perfect analog signal.
So it's a digital transport for an analog source.
Precisely. And the really deep dive part here is how it digitizes it. Thor specifies that this unit uses higher quality 12-bit digital transmission techniques.
12-bit. Okay, for context, standard professional broadcast is usually 10-bit, right?
That's right. And 10-bit is excellent. It gives you about 1 billion colors, great noise handling. But 12-bit, that's 4 times the amount of data.
So it's not just about getting the signal from point A to point B. It's about preserving the nuance. It sounds like the difference between a high-end raw photo file and, an overcompressed JPEG.
That's a great way to put it. That extra bit depth inherently lowers the noise floor.
I see.
And that fidelity is how they can claim it, eliminates those common broadcast problems. Static, color banding, blur. It's why it's used for critical things like video over fiber test systems where you just can't have any signal loss.
That detail really separates the professional gear. So let's talk about the practical side for a minute. What kind of performance can an installation expect? What gives it that incredible range?
The range comes from the single-mode fiber standard. That's what makes the distance possible. This unit will reliably support a fiber optic distance of 20 kilometers.
20 kilometers, that's almost 12 and a half miles.
It is. All uncompressed, multi-channel video and audio over one tiny strand of glass.
So you're thinking massive corporate campuses, remote sports feeds, things like that.
Exactly. And we should also mention it's TAA compliant.
Which is a big deal for government or major corporate jobs, right? It's about where the parts are from.
A very big deal, yes. It matters for secured installations.
So to sum it all up, what this all means for you, the listener, is that the F-2V4A is basically this incredibly robust digital lifeline. It takes these complex, sometimes old analog signals, protects them with this superior 12-bit digital fidelity, and then just ships them over massive distances with a single piece of fiber. It makes signal delivery almost invisible.
Precisely. And that connects to a bigger thought, really.
Go on.
If this 12-bit transmission is the key to getting rid of static and blur for professional signals, it makes you wonder, how reliant is modern broadcast quality on that subtle but clearly crucial difference between a 10-bit and a 12-bit transport system? That's something to mull over the next time you see a perfect live shot coming in from a remote location.